Antarctica is a place of extremes. It is the coldest, highest, windiest, driest continent on Earth. I'm standing off the coast of Ross Island, and if this were a much warmer climate, I would be standing in over my head in water. But since it is so cold here, I'm standing on solid ice. As I look out in front of me, I can see Black Island off this way, and again, if this were a much warmer climate, I would need a boat to get out to that island. I can also see Mount Discovery, a volcano that was active about 5 million years ago. I can also see the Transantarctic Mountains, which span the continent. Now, Antarctica has not always had such an extremely cold environment. It used to be much warmer, and something happened to change it to the cold polar climate that it is today. Many scientists are asking questions about how and why this happened. Did it happen quickly? Did it happen slowly? Did it happen all in one big event that froze over the continent? Or did Antarctica warm and cool, acting as a much more dynamic continent? I'm here with the ANDRILL scientists who are drilling through the ice, through the water, to get to the hard rock sediments below. These hard rock sediments are giving scientists key clues to answer these questions. Last year, ANDRILL drilled through the ice shelf, which is about 85 meters thick, and they recovered over 1,200 meters of rock core that began to answer some of these key questions. This year, ANDRILL has returned to drill a second hole. This is on the sea ice, which is much thinner. It's about 8 meters thick. And this new drill set promises to continue the story of last year's drill core, offering new insight into how Antarctica has played a role in the changing climate over the past 65 million years. Antarctica is recognized by the international community as a place to be preserved and protected, both for its immense beauty and for what it can offer to scientific research. The continent is protected by the Antarctic Treaty, which was signed in 1959 by 12 countries. Currently, 45 countries have signed the treaty, promising that they will not fight a war in Antarctica or drill for oil or minerals. Ongoing experiments are conducted by more than 4,000 scientists of many nationalities with a variety of research interests, including geology, biology, physics, and astronomy. Humans do not live on the continent permanently, and there is no evidence of any existing or prehistoric indigenous population. Only plants and animals that have adapted to the extreme cold are able to survive here. Antarctica has many different types of ice. Sea ice floats in the sea and melts off each summer, refreezing during the winter. Ice sheets are thick, glacial blankets of ice that sit on top of land masses. There are two major ice sheets in Antarctica: the East Antarctic Ice Sheet and the West Antarctic Ice Sheet. These large ice sheets feed the ice shelves that hang onto the edges of the continent. Since ice shelves sit mostly in oceanic waters, they pose no threat to global sea levels if they melt. However, without ice shelves acting as buffers, these melting ice sheets would have the capacity to raise sea levels several meters, dramatically altering the coastlines around the world. Antarctica is surrounded by the world's stormiest seas, known to sailors as the Screaming 60s and Roaring 40s. A belt of sea ice surrounds the continent and doubles in size during the winter season, leaving only a few areas ice-free at the end of most summers. Oceanographers regard the waters around Antarctica as the Southern Ocean. This ocean is wild and unpredictable, much like the weather patterns across the continent. To keep operations running smoothly, weather forecasters work hard to predict upcoming storms and other nasty weather systems, but this is a difficult task in such an extreme environment.
One of the things that I've been working on, along with my colleagues, is a computer weather forecasting system. Computer weather modeling over the polar regions is particularly challenging for a number of reasons. One is that our understanding of the polar atmosphere and the polar weather is not as good as it is over the tropics or the mid-latitudes. So our basic understanding of how things work here is not as good. And it's that basic understanding that allows us to represent the weather in the atmosphere and everything that happens in our model. So that's one thing that makes it a challenge, our basic understanding. A second thing that makes it a challenge is the fact that there are fewer observations over the polar regions than there are over the mid-latitudes. And in large part, that's because more people live in the mid-latitudes and the tropics than over Antarctica or the northern polar regions.
Our main concern down here is aviation forecasting. It's mainly for flight safety. These aircraft have no other places to return to. So our ability to forecast the weather is high impact.
The weather is what it is, and you can't wish it away. We take a very conservative approach on the weather. My philosophy is the science has been here for millions of years. One more day won't matter. Of course, we want to get them out when we can. Our main goal is to fly safe. And I like to take the same amount of people home with me that I brought.
So right now I'm sitting in a C-17 aircraft, which weighs about 200 tons, and we're sitting on about 6 feet of ice, and below that is 1,100 feet of water. So I'm here to talk to the pilots who fly the planes to McMurdo Station, and they face many different challenges. They have to land on the ice, they have one shot to get from New Zealand to McMurdo, and if something goes wrong, they have nowhere else to go.
We always take off at our max gross weight out of New Zealand. Carry as much gas as we can because we have to have enough gas to make it here, and if the weather's bad, turn around and make it all the way back to New Zealand.
The LC-130 is a pretty unique aircraft. It's a derivative of your standard C-130 that is very common throughout the rest of the world. However, ours are unique because they have the largest skis of any aircraft in the world. There's only 10 of them in active service, and they all fly with the 109th Airlift Wing. The main skis weigh approximately 2,500 pounds each, and the nose ski weighs about 500 pounds. And they allow us to operate in very austere open snow conditions. There may be places that will land after a very careful survey of the area that no one's ever been to before. So that's an exciting challenge, is when we have the opportunity to take this plane to places that no one's ever been before.
I'm a fuel operator here at McMurdo in Antarctica. We fuel helicopters and airplanes, and we transfer fuel from big 2 million gallon bulk tanks to the different areas in town. I think the cold is the most challenging, not only for a human being, but also for all of the machines that we use, all of the heaters that we use, or the pumps that we use to pump the fuel. They are very challenged by the cold weather.
We do. Actually, we got a Delhi penguin out here today. He's no harm though. He's off the aircraft operating area, but if we do get one on the runway, say a penguin, then we get the National Science Foundation, get a herding approval, and the fire department folks, who are the only people approved to go herd penguins and seals off the runway, we'll get them out of here, get them away from the aircraft operations, and so that we don't harm the wildlife.
So we can see how this extreme environment impacts our ability to forecast the weather and how we transport people and equipment across the rugged terrain of the continent. Next time, we're going to look deep into Antarctica's past, going back hundreds of millions of years to see how Antarctica has changed throughout geologic time.